I'm Murray Callender. I'm one of the founders of Eigen. I trained as a chemical engineer many years ago, and I got into digital. I think I learned how to code in one of my first jobs, and I've never looked back. Now, I don't really do much code, but I just love data. I've been looking at how we can structure it and make it more efficient my entire career. So a graph in information terms is like a spider's web, it's like a mesh of data, and anything can be connected to anything. So you have the two things, objects and relations. You have an object, which can be a thing, and then you've got how it's related to other things. So as you relate stuff together, you build up this web, this graph of information and how it's connected. So one of the things that I think is so powerful about a graph is it completely matches how we naturally think about information. If you ever sit down to brainstorm a problem with people, you'll end up drawing circles and arrows on a whiteboard. It's just what we do. We say, oh, we've got this thing and then we've got these other things and they're linked such a way. That's exactly how a graph works. So actually we instinctively understand this. And when you see a graph, you can look at it visually and you get it. Whereas the traditional style relational databases can be very confusing. You can look at it and it's just a load of tables. But the beauty of a graph is you can look at it very visually as well. So it makes it much easier for humans to understand what are we actually modeling here. Traditional databases were designed when disk space was expensive. And so what we were looking to do was to minimize the amount of space it took to store things. And so that meant deduplication. So we are trying to only store things once. So what you're looking to do is come up with a thing called a schema. But the downside is that once you've decided on that structure, you're kind of stuck to it. The difference with a graph is that we're not trying to minimize the amount of storage that we use, because storage is cheap. What we're trying to do is maximize the richness of the information within it. And the other thing is that you don't have to decide your structure from day one. You can actually start and model the piece of the world you know, the piece of knowledge that you want to model. And then as your knowledge grows, you can add to it. And you don't break whatever was reading the knowledge you first put in there. Can you start small? Definitely. And I think that's the key point with a graph. You can get going straight away. You might just know two things, and that's enough. You've got two objects, you can relate them and you're up and running. Take the parent-child example. We can put objects in there and we can call one the parent of the other, and then we can call that the parent of something else. And we can also model things that aren't real. So we can model imaginary objects, so concepts. Like I mentioned system. Well, systems, you can't touch a system. It's a human imagined grouping of stuff. But we can still create an object for it in a graph, and then we can link stuff to it. We might want to know what's the health of something. Like what's the health of all the equipment in this system? And well, actually we can calculate that now because we've got all the equipment in the system. We've been able to model the safety barriers on an asset and link it to all the systems that give you information about the health of those barriers. We've automated the verification of blowdowns. So why they're important in the context of digital is that they're allowing us to solve problems that we couldn't solve before. Because a lot of the stuff we do as humans in work is actually assimilate and synthesize information together. We're looking at things across sources of information. And anyone's job will be doing that, from healthcare to retail to heavy industry. And that's why humans are so valuable in jobs, and they're so difficult to replace with robots, because actually we have this ability to make judgments. And what we're doing is holding in our head a model of how this information relates to each other. So if we want to get to the next level and start to be smarter at work and start to automate things and help humans be more valuable by not doing, say, repetitive stuff, we need to be able to have a place to model these relationships. And that's exactly what a knowledge graph lets us do. It lets us leave the existing systems. We're not talking about replacing them. They're excellent at what they do, but we can put this other layer in now that holds the information about how that information is related to each other. So now we can write code or automate things that can look to the graph as like a map It's like a digital map of your information. It can follow that map, go get the data, and then do something with it. So it's like it's storing the metadata, all that hidden stuff that kind of exists in people's heads, or maybe it exists in a document, but you got to go read that document. So it's giving us a digital home for information that previously has been trapped in people's heads.